Hello geometry students, this is Miss Swig and this is 8.4 notes on trigonometric ratios. And after this video you should be able to identify trigonometric ratios of right triangles and use these ratios to find missing angles and side lengths. So the first page here, you don't really need to write anything down necessarily, but it just shows us that a trigonometric ratio is a ratio of the lengths of two sides of a right triangle. So looking at this triangle ABC, we can write a ratio of side AC over side AB. And then by AA similarity, a right triangle with an acute angle that is similar to every other right triangle with that same acute measure. So we see here that GFH and JKL both have 35-degree acute angles as well as ABC, so all three of these triangles are similar, meaning that all three of these ratios are also equal. And this is where you want to start to jot things down. These are trigonometric ratios that can help us find the length of a missing side. So looking on the left here, we see that in triangle ABC, the sine of angle A, so right here, this angle of large A, is written as the ratio of the length opposite of A, so the leg that it's not touching, to the length of the hypotenuse. So sine A is equal to the opposite over hypotenuse, or side little a over C. In triangle ABC, the cosine is the ratio of the adjacent leg, so the leg that's connected to the angle, so right here would be side B, over the hypotenuse C. And lastly, in triangle ABC, the tangent is written as the opposite leg over the adjacent leg. So in angle A, the opposite leg, or the leg that's not connected to the angle, is this little a over B, which is also written right here. And there's another way to remember this. If you look on the right here, this little study tip, a way to memorize this is SOHCAHTOA. So meaning the sine is written as opposite over hypotenuse. Ka for the SOHCAHTOA, and the C standing for cosine is equal to adjacent over hypotenuse. And lastly, TOA, which means the tangent is equal to the opposite over adjacent. So let's take a look. It's asking us in A here for the sine of angle P. So angle P is right here, and we know if we write SOHCAHTOA on top, that our sine is the ratio of our opposite leg over the hypotenuse. So from P, our opposite leg would be this 15, and the hypotenuse, which is always opposite of the right angle, is 17. So sine of P opposite over hypotenuse, which we know is 15 over 17, or about 0.88. Now we're looking at angle Q here, and it wants to know the cosine. So if we go back up to our SOHCAHTOA, our cosine is the ratio of our adjacent leg to our hypotenuse. So looking at Q, our adjacent leg is the one that's connected to the angle, so that's 15 over our hypotenuse, which again is 17. So it's in fact the sine of P is equal to the cosine of Q. Now let's try these ones. Now they're giving us one angle and a length of a side, and it wants us to find the missing side. So I'm going to start with SOHCAHTOA on top. And I see when I'm looking at this angle, and we can call it whatever we want, let's call it angle A. When looking at angle A, I know that I want to use the adjacent leg and the opposite leg. So let's look up here. Which one of these three SOHCAHTOAs has the opposite and adjacent in the ratio? And if we can see that that is tangent. So we're going to write the tangent, sorry, it's having a little mouse issues there, the tangent of to angle A, so the tangent of 25 degrees, because that's what our angle is here, is equal to our opposite leg, which is in this case x, over our adjacent leg, which is 18. So now all we need to do is solve for x. So we're going to multiply first by 18 on both sides. So on the right side here, the 18s will cancel, and we'll be left with x. And if you use your calculator, there is a tangent button, and the sine, cosine, and tangent are just 2 rows above the numbers. So I find the tangent button, and I put tangent of 25 times 18 is equal to about, give me my squiggly lines, 8.4. So x is equal to 8.4. Now let's take a look at 3b. So 3b, we have 70 degrees, so let's name this angle. We'll just name it angle B. Angle B, and we are trying to find the hypotenuse, and we are given the adjacent leg because it's connected to the angle. So now we need to go up to our SOHCAHTOA and look for the ratio that involves the adjacent and the hypotenuse. So sine is opposite hypotenuse, so we can't use sine. Oh, cosine is adjacent and hypotenuse. So we're going to want to use the cosine of our angle, which is 70 degrees, our angle B, is equal to the adjacent leg, which in this case is 15, over the hypotenuse, which is x. And there's a couple ways we can solve this equation, but I am going to put this cosine of 70 degrees over 1, and I'm going to cross multiply. So I'm going to get 15 on one side is equal to x times the cosine of 70 degrees. And to get the x by itself, I don't have to divide by the cosine of 70 degrees on both sides. And when I plug that into my calculator, I get about 43.9 for my value of x. So now looking at the inverse trigonometric ratios, this just tells us that if we have a ratio and we're trying to find the angle, we can use what's called the inverse sine to find the measure of an angle. We can also use the inverse cosine or the inverse tangent. And if you look here, it says the tangent, if the tangent of A is x, then it looks like tangent to the power of -1. But when you read it, it's actually, you want to say the inverse tangent of x is equal to the measure of angle A. So let's try a few of these. It says use a calculator to find the measure of angle A to the nearest tenth. So we're looking for angle A, which is this angle right here. And I'm going to start by writing SOHCAHTOA right at the top, so it's easy for me to reference. So looking at angle A, I know the opposite side, and I know the hypotenuse. So I want to look for the ratio that involves the opposite and the hypotenuse, which is this first one, the So I'm looking for my sine of angle A is equal to my opposite, which is 18 over 27. So I know that my sine of A, if I plug 18 over 27 in my calculator, or if I can reduce it in my head, is equal to 2/3. Now I have to take that inverse sine, and if you use your calculator, it's actually, you just hit the second button, and it's the same as the sine. So second sine will give you the inverse sine. I'm going to take the inverse sine of 2/3. which gives me about 42 degrees. So this tells me that angle A's measure is about 42 degrees. Now let's take a look at the next one. It says use a calculator to find, we're doing angle A again. So let's look at angle A. Now we have the adjacent side, so 3, or AC here is our adjacent side, and our hypotenuse because it's opposite of my 90-degree angle. So I'm going to be using the cosine because it has my adjacent and my hypotenuse. So I have the cosine of A is equal to 3 over 15, or 1/5. Now I'm going to take the inverse cosine of both sides because these two will cancel and I'll just be left with my angle A is equal to the inverse cosine of 1/5 which is about 78.5 degrees. Okay, so this is the final one, so hang with me here, and we're getting a little long. It says solve the right triangle. So when it says solve, it wants to know every degree angle and every side measure. So we have two sides, so we know we could find the third side by using the Pythagorean theorem. But first, we're going to find the measure of angle x by looking at the tangent ratio. So if I write SOHCAHTOA again on top, I'm going to find this angle, angle x here, by using the opposite side over the adjacent side. So I have 9 over 5 9 over 5 is equal to the tangent of x. So I'm going to take the inverse tangent of both sides. And if I plug that into my calculator, it's going to give me about 60.95. Well, now we know that the three angles, angle x, z, and y, are going to equal 180 degrees. And we know that angle z is 90. So x and y must also equal 90. Since we know x, we can take 90, subtract 61, and find the measure of angle y. So this is going to be about 29 degrees. So 29 degrees is angle y. Angle x is about 61 degrees. And now all we have to do is find our missing hypotenuse, which we know we can use the Pythagorean theorem. So we take 5 squared plus 9 squared is equal to 106. And then if we take the square root of both sides, it gives us about 10.3. So now we have solved that right triangle. So we know every single side length and every single angle. And that is all for 8.4.